Hi everyone. Until now we have seen analyzation of bodies in equilibrium by applying Newton's laws of forces. But before Newton also, some scientists like Bernoulli and Leonardo da Vinci. Leonardo da Vinci is the one who drew the picture of Mona Lisa. He's also made some inventions like flying machine, water pumps and machine gun before Newton before Newton only. So these people analyze the bodies which are in equilibrium by applying certain principle called as virtual work method. So this method this method is used rather than Newton's laws of motion in some cases. So according to Newton and according to Bernoulli and Da Vinci, equilibrium is defined as, according to Newton, a body is in equilibrium if it is at rest or in uniform motion. So in equilibrium of bodies we have seen that a body at rest or a body in uniform motion with a uniform motion is the one which travels with a constant velocity, some velocity u. Then the body is said to be in equilibrium. Whereas in Bernoulli and Da Vinci, these guys said that a body is in equilibrium if no work is done. So if there are number of forces acting on this body, according to Newton, summation of these forces will be equal to 0, which means this is the positive force and this is the negative force considering the directions. So according to Bernoulli and Da Vinci, the work done by this and the work done by this, summation of the work done will be equal to 0. This is what Bernoulli and Da Vinci said. So in case of Newton's laws, summation of forces is 0 and summation of moments is 0, then the body is said to be in equilibrium. But in case of Bernoulli and Da Vinci, summation of work done is 0, it gives the equilibrium of the body. So what is this virtual work method? The total work done by the system should be 0 in order to remain in equilibrium. This is what we have seen by definition of equilibrium considering the Bernoulli and Da Vinci. So virtual work method is the application of this principle. The total work done by the system should be 0 in order to remain the body in equilibrium. So what is this virtual? What is the word virtual mean? So it is the virtual word is given by Webster. He is a scientist. He said that virtual means being in essence of effect but not in fact. Suppose consider a seesaw. This is the seesaw. If a fat guy is sitting here, here a fat guy is sitting, and here a thin guy is sitting. So in order to go up this side, the weight of this body is not enough to lift this body. But this has the effect, but this is not moving up. This force has the effect but not moving down. So being in essence of effect but not in fact, the force is applied but it is not moving. This is called virtual. So by assuming small displacements, the bodies are analyzed, the equilibrium of bodies are analyzed. So virtual work has two approaches. One is virtual displacements and another one is virtual forces. The virtual displacements is the popular one, and we are going to study only virtual displacement, principle of virtual displacement. So let us see what is work done. Work can be done by the force or by the moment. Suppose there is a body here, there is a body and a force is applied and it moves through certain distance s. Then the work done is given by force into distance. The force applied into distance moved by the body in the direction of force. Then what is moment? Work done by moment. If there is a link like this, there is a weight here and a moment is applied here. This moves through angular displacement theta. If this rotates through angle theta, then the work done by the moment is given by moment into this angle theta. This theta is called angular displacement. So work done in case of force is force into displacement, and work done in case of moment is moment into angular displacement. Here S is displacement and here theta is angular displacement. So while solving the problems, we need to follow certain sign convention for work done. Many books say different sign conventions, such as uh, the right side should be taken as positive and left side should be taken as negative, and some others follow like in the direction if the motion is in the direction of force, then the work done should be taken as positive. Like that, many sign conventions are referred by some textbooks. Let us follow a sign convention like this. This will be very easy for us to remember, or easy to simplify. So the sign convention we follow for the work done is, if displacement is in the direction of force, work done is positive. So this is the body and force is applied and this body is moving in the direction of force. So the displacement is in the direction of force, then the work done is positive. If the displacement is opposite to the direction of force, then the work done is negative. In case of moment, we have seen that work done can be by force or by moment. In case of moment, if there is a moment like this, and if theta and if angular displacement is in the direction of moment, it is positive work done, and if it is opposite, that is opposite direction to the direction of moment, then it is negative work done. This is the sign convention we follow. It is very important to remember the sign convention. So we use del for virtual and d for real. In case of this chapter, we use only this because we are not dealing with real displacement. We are dealing only with virtual displacement. So in GATE exam, the questions will be asked in such a way that the formula derivation questions will be asked. So let us see how we apply work energy principle. The first example is derive the formula for theta. So this is the problem. There is a bar here and two links are attached. These are two links attached to this bar, and these are These two links are attached to this rod by two hinges, and there is a weight here. This is a block. So it has weight mg and a moment is applied here. The angle made by these links with vertical is theta, and he is asking to find the formula for theta. That is, when moment m is applied, then what is the relationship between theta and this mass and this height. Let us say this height is h, and the length of the link is b. So this is b, this is h. So if moment is applied, we have seen that a small displacement is taken to analyze this type of problems. So if we apply moment m, in real the displacement is not there, but this is a virtual work method, so some displacement, small displacement should be considered. So by applying this moment, this block moves somewhat upwards, and this point changes to here, this point changes to here, and if I draw the link, it becomes like this, and here it will be like this. So let us say this change in angular displacement is delta theta, and the change in height, let me draw this with a straight line, and the change in this height is given by delta h. The small change in displacement is delta h, and small change in angular displacement is, let it be, delta theta. So this is the assumed position of this block when moment m is applied. So here we can see that this forms a triangle, right? If we consider this, h is given by b cos theta, because cos theta is given by adjacent side by hypotenuse. The adjacent side for theta is h, and the hypotenuse is length of the link, which is b. So h is equal to b cos theta. So in virtual work method, what is virtual work method? Virtual work method is total work done should be 0. Total work done should be 0. So in this system, work can be done by this force mg, and work can be done by this moment. So there are two types of loads. One is weight and the other is moment. One is weight of the body, and another is moment m. So virtual work done by mg. What is virtual work done by mg? From this figure we can see that by applying moment, the body is lifted upwards, but the weight is acting downwards. Weight is acting downwards and the body is moving upwards, which means the force and the direction of motion of this body are opposite in direction. So the virtual work done by mg, I have said that the virtual is represented with delta. So virtual work done by mg is given by mg into delta h. This is the force, that is weight, and the distance moved by this block is delta h. Here we can see the distance moved by the block is delta h. Since the force and the direction of motion are different, the by sign convention, the work done by this body is negative. So what is the value of delta h? We have got here that h is equal to b cos theta. Differentiating this with respect to theta, delta h is equal to, differentiating with respect to theta, b is constant and differentiation of cos theta is minus sin theta. So delta h is equal to minus b sin theta d theta. So while taking the displacement, we need to take the only magnitude of displacement, and the direction should not be considered because we have already made the sign convention that the direction of force and motion are opposite, then we take it as negative. So the sign convention is already taken, that's why we need to take displacement as only magnitude. So b sin theta d delta theta is delta h, which is equal to minus mg into b sin theta del theta. This is the virtual work done by mg. And there is another one, moment. Work done by moment is moment into angular displacement. Work done by force is force into displacement. Work done by moment is moment into angular displacement. If you see here, by applying moment m in this direction, the angular displacement is also in the same direction. So sign convention for this is positive. Virtual work done by moment is equal to positive moment m into delta theta. So this is the virtual work done by moment. What is virtual work method saying? Total work done is equal to 0. Total work done should be 0 to remain the system in equilibrium. Total work done is equal to 0. That means work done by mg and work done by moment, by adding these two, we should get the total work done as 0. So delta w mg plus delta w moment should be 0. So what is virtual work done by mg? Minus mg into b sin theta delta theta, and the virtual work done by moment is m into delta theta plus m into del theta is equal to 0. And this becomes, if we send this to this side, m into del theta is equal to mgb sin theta del theta. These two get cancelled and the theta will be, theta is sine inverse of moment divided by mg into b. This gives the relationship between theta and moment and weight and the length of the link. This is how we solve problems using virtual work method. Let us see the next problem. Find the relationship between weights of the blocks and angles of inclination if coefficient of friction is 0. So there are two blocks here. There is a block P and block Q, and these are resting on both inclined planes. One is inclined at angle theta 1 and another is inclined at angle theta 2. The question asked here is relationship between these weights P and Q and the angles theta 1 and theta 2. So there is a pulley here, which is these P and Q are joined by an inextensible string here. Let us suppose that in virtual work method we assume a small displacement delta s. So let us assume that this Q is moving downwards and P is moving upwards. You can assume P moves downwards or Q moves upwards. In this problem, let us consider Q moves downwards. As the weight let us say the weight is Q, here the weight is P. And there will be, this is theta 2. Let me zoom in here. The weight acting downwards. This is theta 2. And this is W. This is W sine theta 2. This is W cos theta 2. Since this is adjacent and this is the opposite side, this is W sine theta, it is Q, right? Q sine theta 2. This is Q cos theta 2. Since we have said that the weight acting by the body Q is Q, and there will be a normal reaction. There will be a normal reaction, say N2. Similarly, on the side P, this is theta 1. So this will be P sine theta 1, since this one is opposite side, and this will be P cos theta 1, and there will be a reaction equal to N1. So if we consider certain displacement, a small displacement delta s, so Q moves a certain distance delta s downwards, and P moves certain distance. P moves certain distance up, which is same delta S. Then the work done by Q, the force in the direction of motion, by weight Q is this one, Q sine theta 2. The force is Q sine theta 2, and the in this direction displacement in this direction is delta S. This is what virtual work done by the body Q. And similarly, virtual work done by the body P is P sine theta 1 in the direction of motion. This is P sine theta 1, this one, into delta S. So now giving the sign, this body has force in the direction of motion, but here in Q body the force and the direction of motion are same, and in P body the direction of force and the displacement are in opposite direction. The force is acting downwards, but the body is moving upward. So the work done by the force P is negative. And what does virtual work say? Virtual work method, total work should be total work should be 0. The work done by Q plus work done by P should be equal to 0. Work done by Q is Q sine theta 2 into delta S, plus what is work done by P, minus P sine theta 1 delta S, which should be equal to 0 in order to remain the system in equilibrium. If you send this to here, Q sine theta 2 into delta S is equal to P sine theta 1 into delta S. This delta S gets cancelled, and the remaining is, if I send P to here, P by Q is equal to, and sine theta here, sine theta 2 divided by sine theta 1. So this is the relationship between the weights P and Q and the angles of inclination. And let us see another problem. So this is the one. Find the value of F to load the frame into equilibrium under the action of force P. Each link is 2a in length, and the angle theta is 45 degrees. So there is a load acting P here, and a force F should be applied in order to maintain this system in equilibrium. So how do we solve this problem? If we consider it is symmetry about this axis, so we consider this right side section. There are work done by F and work done by P. These are the two forces, and two works can be done. Now let us assume that the direction of motion is in the direction of force F. So if this link moves here, if this link moves like this, at P it moves upwards. So one will be in the direction of motion, in the direction of force, and the other will be in the direction in opposite to the direction of force. So if we consider the displacement is in the direction of force F, the displacement at P will be opposite to the direction of force P. So virtual work done by force F is given by force into this delta y. Let us say the small displacement is delta y and this is y. So what is y then? If you see here, this is theta and this is opposite side. So y will be a sine theta, because this length is a, this is hypotenuse and this is opposite, so y is a sine theta, and x is a cos theta. If we differentiate this with respect to theta, delta y by delta theta is equal to a into cos theta. Differentiation of sine theta is cos theta. So delta y will be a cos theta delta theta. Similarly, delta x will be, let me write here. So x is a cos theta, which means delta x del x by del theta is equal to a is constant and differentiation of cos theta is minus sine theta. Delta x becomes minus a sine theta del theta. But we are considering the direction of motion in, the sign convention is already considered, so the displacement should be taken only as magnitude and the direction is neglected here. A sine theta del theta will be the delta x. So virtual work done by force F is F into delta y. What is delta y? Delta y is a cos theta del theta. A cos theta del theta is work done by force F. Then what is work done by force P? We are considering only the right side section. So this P is divided, here it is P by 2 and here it is P by 2. So P by 2 is the force acting on the right side. Virtual work done by, this is actually P by 2. P by 2 is equal to load into, what is the distance? It is delta x. So this is the x direction, right? This is x. X is equal to a cos theta, and this moves upwards, so it becomes like this, and this distance is delta x. So we have found out delta x value as a sine theta del theta. Here sign convention should be negative. Negative sign convention, because the direction of force is downwards, that is P by 2, which is downwards, and the direction of motion of this link is upwards, which is delta x. The displacement delta x is upwards. That's why the work done will be negative. So minus p by 2. What is delta x? A sin theta del theta. A sin theta del theta. So by virtual work method, total work done should be equal to 0. The work done by force F and work done by force P by 2 should be equal to 0. Work done by force F is F into A cos theta del theta, and work done by P by 2 is minus plus minus P by 2 A sin theta del theta, which should be equal to 0 in order to remain the system in equilibrium. So by sending it to the RHS, F into A cos theta del theta is equal to P by 2 into A sin theta del theta. Delta theta gets cancelled. A and A gets cancelled. So what we need is force F in terms of P. F is equal to P by 2 sin theta. If we send cos theta to this side, divided by cos theta. So F is equal to P by 2 tan theta. So this is the relationship between F and P. And also, is the value of theta given? Yeah. Theta is given as 45 degrees. If you substitute that value of theta in this, F is equal to P by 2 tan 45 degrees. So tan 45 is 1 and F is the half of the load applied, that is P. Half of the load applied is P by 2. So this is how the problems using virtual work is done. And generally problems like deriving some relations are asked using virtual work method. If this video is helpful, please like and share with your friends and subscribe to this channel.